How one Chinese company just ended the TSMC NVIDIA monopoly. Might sound like an exaggeration, but by the time you finish this video, you'll see why it is not. Right now, TSMC alone controls roughly 90% of the world's most advanced chip manufacturing, a choke point so tight that if its top fabs went dark, the global economy would start seizing up before most governments could even hold an emergency briefing. You heard that right. But in Shanghai, a single state-backed foundry has quietly done what Washington, Wall Street, and Silicon Valley all swore could not be done. It has started prying open that grip without access to the very machines the West said were absolutely essential. In the next few minutes, you are going to see how SMIC hacked around the rules, bent old tools to new limits, and helped China build a chip ecosystem that no one outside the country is truly prepared for. And to understand just how explosive that is, you first need to see how TSMC and NVIDIA became the two towers the entire modern world was built on. The two towers. You are standing at the base of what might be the most powerful industrial structure ever built. Two towers that together control the hardware running the modern world. TSMC, Taiwan's semiconductor manufacturing company, sits on one side. Founded in 1987 by Morris Chang, it started with a radical idea that sounds obvious now, but was revolutionary then. Stop trying to design and build chips yourself. Just be the best builder in the world for everyone else's designs. A pure-play foundry, they call it in the industry. Apple hands over the blueprints for its A-series and M-series processors. NVIDIA sends specs for its GPUs. AMD, Qualcomm, Broadcom, even defense contractors feeding the US. Military, they all do the same. TSMC turns those digital designs into physical silicon. At its most advanced nodes right now, pushing 2 nanometers, it etches circuit features so fine they're smaller than a strand of your DNA. The scale hits different when you run the numbers. TSMC controls roughly 90% of the world's most advanced chip manufacturing. You heard that right, 90%. Imagine one power plant supplying nearly all the electricity for an entire continent. If TSMC's cutting-edge fabs went dark for even a month, every flagship smartphone, every AI data center, every advanced weapon system would start running dry before the ink dried on the headlines. But TSMC doesn't stand alone. Across from it rises the second tower, NVIDIA. NVIDIA began as a gaming company, building graphics cards that made Quake and Half-Life look like movies. For decades, that was their lane high-end GPUs for gamers who wanted ray tracing and maximum frame rates. Nobody outside esports arenas paid much attention. Then, artificial intelligence rewrote the rules. Researchers stumbled onto a truth. The same parallel processing architecture that rendered explosions in video games was freakishly good at something else entirely: training neural networks. NVIDIA's chips could handle thousands of calculations at once, exactly what machine learning craves. Hardware alone wouldn't have built the tower. What sealed NVIDIA's dominance was CUDA, their software platform that lets engineers program the GPUs. By the time ChatGPT and the AI boom hit, an entire generation of PhDs had built their careers on CUDA code. Switching to a competitor wasn't just expensive, it meant torching years of work and starting over. NVIDIA's A100 and H100 GPUs became the undisputed engine of the AI revolution. Every model you've interacted with, GPT, Gemini, Claude, Grok, all trained on stacks of those chips. NVIDIA's market cap blasted past $2 trillion, making it one of history's most valuable companies, fueled by a near-perfect hardware-software lock that nobody had cracked. Now see the pipeline these two towers created. TSMC fabricates NVIDIA's chips. NVIDIA's chips power the AI economy. Two companies, one dependency chain. Nearly every government, every military, every tech giant on Earth sits downstream, consuming the output, praying the flow never stops. China mapped this dependency years ago. It ran the audits, traced every critical chip back to its source. And the audit revealed something that kept Beijing awake at night: not just vulnerability, but total exposure. But before China could move to break that chain, The United States struck first with a policy so sweeping it was supposed to end the threat before it ever materialized. And it changed everything. The sanctions that were supposed to freeze China in time. You're watching the most aggressive economic weapon in modern history take shape, a policy designed not to destroy, but to permanently stall an entire nation's technological future. October 7th, 2022. The Biden administration unleashes what experts immediately call the broadest export control package since the Cold War. The target isn't missiles or fighter jets. It's silicon, the raw material of the 21st century. The goal is brutally simple: choke off China's ability to manufacture advanced semiconductors at any competitive scale. What gets blocked reads like a chip factory's inventory list. Advanced manufacturing equipment, the plasma etchers, chemical vapor deposition chambers, atomic layer deposition tools that build chips layer by nanoscale layer. EDA software, the digital drafting tables, where engineers design circuits smaller than viruses. American citizens and green card holders suddenly need special licenses just to work at Chinese semiconductor firms. And then the kill shot, ASML. You need to feel the weight of that name, because ASML is where this story pivots hard. This Dutch company builds extreme ultraviolet lithography machines, EUV for short. Picture a device so complex, it ships in 40 cargo containers, costs $300 million, and took decades for humanity to invent. These machines fire lasers at droplets of molten tin traveling 100,000 miles per hour, generating light so extreme it etches circuit patterns finer than anything else on Earth can achieve. They're the only tool that makes 2-nanometer chips possible. ASML has a total monopoly, no competitors, no alternatives. China was now locked out completely. The logic felt bulletproof. Without EUV, no advanced nodes. Without advanced nodes, no competitive AI chips. Without competitive AI chips, China falls years, maybe decades behind. Washington policymakers slept easy. Industry analysts nodded along. The consensus across Silicon Valley and intelligence agencies rang clear. You simply cannot manufacture cutting-edge semiconductors without those machines, period. To make it land personally, imagine you're an automaker, told you can build cars, but not import engines, transmissions, or software, or hire anyone who's ever worked on a drivetrain. China's position was that suffocating. Every door they approached slammed shut. The pressure didn't let up. 2023 brought new rules, closing every loophole. 2024 tightened the noose further. Even NVIDIA's specially neutered China chips, the A800 and H800 models engineered to barely skirt export limits, got axed. The message from Washington screamed absolute. We will burn every bridge you try to cross. Everyone bought the premise. Chip executives, think tank experts, even Chinese industry watchers figured SMIC would limp along on older tech, relegated to making yesterday's chips forever. The sanctions weren't just policy, they were physics, or so the world thought. Then came the most devastating news of all. Not for Beijing, for everyone who had bet the farm on that unbreakable assumption. Deep inside SMIC's Shanghai fabs, yield charts that had flatlined for years suddenly ticked upward. Engineers who'd spent careers reverse engineering Western tools started layering tricks nobody predicted. The machines China had, the older DUV litho tools, began doing things they were never designed for. And the US strategy that was supposed to freeze time? It lit the biggest fire under China's semiconductor push anyone could have imagined. Because what happened next, inside one unassuming smartphone, would crack the entire narrative wide open. The phone that broke the narrative. Imagine picking up a smartphone that wasn't supposed to exist, a device that, in its silicon heart, carries proof that the world's most sophisticated economic warfare just suffered its first major defeat. September 2023, Huawei drops the Mate 60 Pro. No global launch event, no flashy keynote. The phone simply materializes on shelves across China, available to anyone with cash or credit. Tech enthusiasts and analysts smell something unusual immediately. Huawei's been on America's blacklist for years, cut off from advanced chips entirely. Curiosity turns to obsession. Within days, teardown teams have the device in pieces. They X-ray it, dissolve its epoxy, probe every die with electron microscopes. The discovery lands like a gut punch. Inside beats a 7nm Kirin 9000 processor fabricated by SMIC. 7 nanometers. Let that node name echo. This was the exact manufacturing process U.S. export controls targeted to block. The process every intelligence assessment swore required EUV lithography, the $300 million ASML behemoths Beijing couldn't touch. SMIC's public roadmap topped out at 14 nanometers. The leap to 7, at consumer scale, without forbidden tech, Western analysts called it impossible. Physically, economically, every way. Panic ripples through think tanks and boardrooms. How? The answer SMIC eventually confirmed reads like engineering black magic. Multi-patterning with DUV lithography deep ultraviolet. The previous generation tool that's not export restricted. Here's how you picture it. EUV is a sniper rifle. One impossibly precise exposure pass etches an entire chip pattern into silicon. DUV multi-patterning is a painter with a fine brush, forced to layer stroke after stroke, 4 passes, 5, sometimes 6, building complexity through repetition. Each extra pass means more time, more heat, more defects. Wafers warp under thermal stress. Yields crater, meaning far more chips die in quality control than TSMC ever sees at the same node. Costs skyrocket per working die. But the survivors? They pass every benchmark. They power a flagship smartphone. They ship by the millions. And they prove every embargo assumption catastrophically wrong. The shockwave didn't stop at 7 nanometers. By early 2025, whispers became reports. SMIC hit 5 nanometers. Same DUV trickery, pushed beyond what textbooks said was viable. Huawei's next-gen designs flowed straight to those lines. Capacity ramped relentlessly. SMIC's utilization rates climbing past 90% as domestic orders flooded in. You heard that right. 5 nanometers, no EUV, shipping silicon that runs real workloads. Western headlines screamed, "Catch-up miracle." But insiders saw the real story. This wasn't luck or one-off wizardry. It was 3 years of state-directed engineering fury fabs running 24/7, PhD teams sleeping on factory floors, every failure dissected like a crime scene. The sanctions, meant to paralyze, had forged the most determined chip-making machine on Earth. China didn't just dodge the chokehold. It weaponized the pressure, turning yesterday's hand-me-down tools into tomorrow's strategic arsenal. But breakthrough silicon is just table stakes. A chip's worthless without the full ecosystem breathing life into it, and that's where China's ambition reveals its true, terrifying scale. Because while SMIC etched ever finer lines, an entire parallel semiconductor universe was rising around those fabs funded at levels that make Silicon Valley look like a lemonade stand. The ecosystem. China's bet on total independence. You've seen the chip breakthrough that shocked the world. But that's merely the visible edge of something far more sweeping: China's methodical construction of a semiconductor universe that no foreign government can ever switch off. Most coverage fixates on SMIC's lithography hacks, treating them like a solo magic trick that's missing the forest for the transistors. A modern chip demands an entire industrial stack, and Beijing methodically attacked every layer after the sanctions hit, building domestic replacements with ruthless efficiency. Start at the foundation: raw materials. China already dominates global supply of gallium, germanium, and high-purity graphite inputs, so critical that in 2023, Beijing flipped the script with its own export bans. Western fabs suddenly scrambled as their assumed endless pipeline of cheap Chinese chemicals dried up. You heard that right. The country everyone thought they could sanction was now holding the material chokehold. Next layer up: equipment. The etch chambers, deposition tools, metrology scanners that fill a fab's cleanroom floor. Companies like Nora Technology and advanced microfabrication equipment scaled from niche players to national champions, vacuuming up state contracts and subsidies. Their plasma etchers now handle what ASML's forbidden tools once did exclusively: Not perfect parity yet, but closing fast enough to keep SMIC's lines humming. Then, the invisible backbone, EDA software. Those are the digital drafting tables, where engineers lay out billion transistor circuits, atom by atom. America's Synopsys and Cadence owned that market until export controls cut Chinese firms off. Domestic alternatives from Empyrean and Primarius exploded, backed by university brain trusts and government mandates. Chinese chip designers now work in Chinese tools, feeding layouts straight to SMIC without a byte crossing US servers. At the design pinnacle sits Huawei's HiSilicon, churning advanced architectures entirely in-house mobile SoCs, AI accelerators, server chips. The old TSMC model, where fabless giants like Apple and NVIDIA ship designs to Taiwan, now runs domestically, with HiSilicon blueprints hitting SMIC's multi-patterning lines the moment they're finalized. None of this erupts without obscene money. Enter the big fund, China's nuclear option for semiconductor dominance. Phase 1 in 2014, $20 billion. Phase 2 in 2019, $30 billion more. Then the monster. Phase 3 in 2024, $47 billion, the single largest chip investment pool ever assembled by any nation. Provinces piled on with their own billions, turning Shenzhen and Shanghai into semiconductor moonshot zones. SMIC drank deep from that fire hose. Its 2025 capex hit $8 billion, fueling new fabs from Beijing to Shenzhen. Revenue surged past $9 billion, utilization rates locked at 94%, as domestic giants Huawei, Xiaomi, automotive suppliers placed orders too big to fill. Profit margins squeezed under expansion costs? Sure, but factories maxed out don't lie. This was industrial mobilization at wartime scale. The genius of the strategy lands here. China never planned to out-TSMC overnight. The goal was simpler, more unbreakable, a self-contained ecosystem where every critical chip for national security, AI sovereignty, military edge gets made on Chinese soil, with Chinese tools. Chinese code, Chinese materials. Cost more? Fine. Yield lower? Acceptable. When your rival can embargo your existence with a signature, domestic silicon at any price becomes the ultimate bargain. Western analysts called it wasteful overreach. Beijing called it survival math and bet a generation's treasury that dependence was the real waste. For Musk, the bigger problem wasn't just the fabs churning without EUV, it was watching an entire parallel chip world solidify around them, one that TSMC and NVIDIA could only watch from the outside. But here's where the story turns brutally realistic, because even with miracles and money, can SMIC actually threaten the global foundry king? Can SMIC actually challenge TSMC? You're now facing the raw, unfiltered question that haunts every chip executive from Hishin Chu to Silicon Valley, with SMIC's relentless surge. Does it truly threaten TSMC's Iron Throne, or is this just a billion-dollar national flex that fades under scrutiny? Lay out the scorecard without mercy. TSMC ships 2nm production today across multiple fabs, with 1.6 nanometers already in risk production features, so microscopically precise. They pack transistors denser than the influenza virus, floating in your bloodstream right now. Every halving of process node doesn't just shrink size, it squares performance gains, slashes power draw, unlocks entirely new chip architectures. This is physics compounding on itself, decades of Taiwanese mastery distilled into silicon supremacy. SMIC? 7 nanometers runs at full throttle, 5 nanometers in aggressive ramp. That's not a gap, it's generational Grand Canyon territory. Yields hammer the point home. TSMC routinely extracts 90% good die from each wafer, a surgical ballet of process control refined over 20 years. SMIC's DUV multi-patterning workaround? 60 to 70% on its best days, often dipping lower when thermal stresses warp those painstakingly layered exposures. Defects don't just appear, they cascade through the stack, turning promising wafers into expensive scrap. One TSMC leading-edge wafer might birth 200,000 working chips. SMIC's equivalent struggles to clear 100,000. Costs? Double, triple per viable die when you factor endless rework. Capacity crushes the dream further. TSMC's global empire Taiwan heartland, Arizona expansion, Japanese outposts pumps out millions of leading-edge wafers monthly, absorbing blank checks from Apple, NVIDIA, AMD. Every big tech giant betting their future on flawless scale. SMIC scrapes under 1 million total wafers annually across all nodes, advanced included. Customers don't switch from 90% reliability to 60% optimism. They stick with what ships, works, scales. China's genius was never chasing that global crown. They built an impenetrable domestic fortress tailored to the world's largest semiconductor appetite, $400 billion, yearly sucked into phones, electric vehicles, data centers, smart factories, defense systems. Most of that volume? Mature nodes that don't need bleeding-edge magic. 14 nanometers powers automotive ECUs, radar arrays, infotainment stacks for BYD's electric fleets flooding Chinese roads. 28 nanometers drives networking switches, home appliances, industrial controllers, keeping factories humming 24/7. 40 nanometers and coarser? Ubiquitous sensors in everything from security cameras to medical devices. SMIC already owns that mature node kingdom outright fabs, locked at 95% utilization, revenue surging 16% to $9 billion, even as expansion costs squeezed margins. Domestic titans queue up, BYD demanding car chips by the million, Xiaomi feeding handset lines, state infrastructure projects vacuuming everything else. That cash flow isn't charity, it's rocket fuel for the advanced node push, turning yesterday's workhorse silicon into tomorrow's strategic weapons. The advanced story lands even harder. 7 nanometers already drives Huawei's flagship Kirin processors, outperforming embargoed rivals in real-world phones shipping by the tens of millions. 5 nanometers scales next for AI accelerators and server beasts, not TSMC cheap, but utterly embargo-proof. When a presidential signature can overnight choke your military satellites, national AI grids, or defense supercomputers, paying double for domestic certainty isn't a luxury, it's survival math. Every province issuing Buy Chinese silicon mandates, every state lab speccing SMIC over Taiwan, slices tens of billions from TSMC's recurring revenue artery, not a single punch knockout. 1,000 calculated cuts, province by province, contract by contract. SMIC's momentum seals the verdict. $8 billion annual capex erects new clean rooms from Shanghai's glittering skyline to Shenzhen's hardware hustle and Sichuan's inland industrial heart. Utilization stays superglued at 94% demand, wildly outstripping supply. They're not overtaking TSMC next quarter, but methodically eroding the monopoly's bedrock node by node, customer by customer, year by grinding year. That's not hope. That's arithmetic. Wall Street pretends not to notice. TSMC remains the undisputed king. No informed voice claims otherwise. But that invincible psychological moat, the bone-deep certainty that no rival could ever scale to threaten SMIC, just poured dynamite down it and lit the fuse. For NVIDIA, though, the assault sliced far deeper, straight through the AI heart no export control or physics law could shield. The AI chip wildcard. America played its strongest card. Ban NVIDIA's elite GPUs outright. A100, H100, even downgraded A800, H800 compliance models. No world-best silicon, no world-best AI. Or so the script read. Pentagon briefings, NVIDIA earnings calls, all nodded along. Huawei's Ascend series crashed the plot twist. Pre-ban development met post-ban desperation. Chinese labs bet their futures on it. Baidu, ByteDance, Alibaba rewrote entire codebases overnight, forging CAN and MindSpore frameworks to mirror NVIDIA's CUDA lock-in, native from silicon to software, optimized for domestic clusters. Ascend 910C specs, draw blood, 800 teraflops, FP, 16, compute on SMIC's 7 nanometer lines, H100 hits 989, raw gap persists. But power efficiency flips the board 310 watts versus 700. Million chip data centers running Chinese silicon/electricity bills by half. Software tuning closes performance to 75% through custom kernels and memory hacks. Constraint-forged genius. DeepSeek sealed the proof. This Chinese model matched GPT-4 tier results on a third the compute. Some claimed a tenth. Algorithms helped. But necessity ruled. No infinite H100 racks means smarter engineering, every flop maximized. Baidu's Ernie, ByteDance's Dubao, state surveillance nets. All native Ascend, no foreign strings. China's AI hardware spend 50 billion yearly. Racing toward 100 pours inward. Every cluster built means NVIDIA revenue evaporated forever. Gap shrinks yearly as SMIC hits 5 nanometers, then 3. Ecosystem stickiness grows. Chinese PhDs train on CAN now, not CUDA. NVIDIA leads. H100 reigns. But the unassailable moat, Ascend, just swam it. Monopoly math inverted. Not broken, but bleeding. One company broke it all. Flashback to your click. TSMC strangling 90% of advanced manufacturing. One Taiwanese foundry dictating the silicon heartbeat of smartphones, AI empires, fighter jets. NVIDIA's $2 trillion juggernaut, CUDA shackling a generation of engineers. H100 clusters birthing every chatbot whispering in your ear today. EUV is the ultimate gatekeeper. $300 million monopolies no rival could touch. SMIC didn't just slip the noose. It forged its own blade from the rope. DUV multi-patterning, that desperate yield-killing layering ritual, birthed 7-nanometer millions for Huawei flagships. Then 5-nanometer scale, where every physics textbook and intelligence dossier screamed, impossible. Big Fun's third-phase nuke $47 billion alone, on top of $50 billion prior, didn't just fund fabs. It resurrected entire supply chains. Nora etch tools matching forbidden Western gear. Empyrean EDA drafting atomic blueprints. Gallium mines flipping export bans back on scrambling Americans. Huawei's high-silicon pump design straight to SMIC's humming lines, while Ascend clusters spawned DeepSeek frontier AI devouring a third the compute of GPT-4 class beasts. China's $400 billion chip abyss became SMIC's endless feast, mature nodes, bankrolling advanced conquests. 95% utilization, turning Shanghai into the world's stealth silicon engine. Every BYD electric SUV, Xiaomi phone, state surveillance camera fed the beast, while 7-nanometer flagships and 5-nanometer AI runs proved embargoes breed monsters. The towers didn't fall from perfect silicon or matched yields. They crumbled under certainty's collapse. That bone-deep global faith, no alternatives exist, at any price, for any purpose, SMIC torched it alive. You heard that right. One Chinese foundry, state ignited at total war scale, proved when you embargo a civilization's lifeline, it doesn't kneel. It builds an empire fab screaming 24/7, clusters rising where H100 CES can't reach, provinces mandating silicon sovereignty, while TSMC bleeds tens of billions and NVIDIA watches its China moat drain dry. The grip doesn't just slip, it shatters. TSMC feels orders evaporate eastward. NVIDIA confronts Ascend racks, outpacing H100 efficiency in raw economics. One Shanghai company etched the ending not in flawless 2-nanometer perfection, but in unbreakable independence, the monopoly fueling the modern world. Its final chapter just shipped from a clean room you never heard of, wafer by Defiant Wafer. The era of untouchable giants closes tonight.